by following the exercise one. This is the explanations for the exercise two. Um, this the method. The intention of this question is seems to be it seems to implement the functionality that allows you to print the element and height of the each node in the binary tree. So it was asked, I was asked to traverse the tree in a specific order to visit each node and calculate the height of the node, where the height is defined as the number of the edge of the longest path from the node to the leaf, and print the node element and its height after visiting. So the goal is to implement a binary tree where we can add a node, we can compute the print, the height of the node using the post order traversal. Let me go straight to the code added to the file. Here is the lesson 8 example. In that, I went to I used the Java code called the linked binary tree. Um, Here is the editor code. Print position and height method. This method is the starting point for printing the element and height of each node in the tree. The purpose is simply called the helper method. Uh, this one, starting from the foot of the tree, it initiates the process of the post-order traversal to print out the element and height of each node. Print position and height post order method. This method is responsible for performing the post order traversals and printing each node element and height. The post order traversal visits the left subtree first, and then the right subtree, and finally the node itself. So this is a base case. This is a basic case if the position is null. Uh, this method to perform a post-order traversal, first it recursively visit the left and the right subtrees, and then it process the node itself by printing its elements and height. And then height calculations. After visiting the subtrees, it calculates the height of the current node using compute height method. Let me move to uh, the compute height method. This method calculates the height of the subtree rooted at the given node. The height is the number of the edge on the longest path from the node to leaf. So this is the base case. If the position is null, it returns -1. And these two are calculate the height of the left and right subtree. Here's the return. The height of the current node is 1 plus the maximum of the height of its left and right subtree. So as a purpose of this code, we can say that base code, when it comes to base code, if the position is null, it returns -1 indicating no node is present. And when it comes to recursive case, it computed it computes the height by recursively calculating the height of the left and the right subtrees and then returning one um, the returning the one plus the max number. This formula ensures that the height of the node is 1 plus the height of the tallest subtree. Let me go to the method. This is a code to use to create a sample binary trees, add a node to it, and then different elements and height of each node in the tree. So when I look at result, the result is like this. Thank you.